back here. Present slides, start presentation. There we go. Good. All this technology, I'm too slow. So I hope you're all feeling good today. Ready for another round? That I'm back in Halifax today. You can always tell by my background. If it's a bright white background, I'm in Kingsburg, and if you see a bookcase, then I must be in Halifax. Uh, we just got back from a walk, and it's sort of very dreary here in Halifax right now, if you're not here. Very gray sky. I suppose we're supposed to get some sun. And the disappointment coming from the country coming in here is with the melting and the salt and the roads and that type of thing. The snow is now starting to get dirty in Halifax, and down Kingsburg and anywhere out in the country, it's still bright white, really nice. Dora loves the snow. She doesn't like the salt. Hurts her paws. So, okay. I promised you today we'd start the class by looking at the assignment and if you've got questions. So before I get going, I've got comments on every question. These are ones that we had a meeting with the Math Help Center staff and some of the other instructors to go over what questions people have started to see coming in. And hopefully we can respond to a number of those sorts of issues. So you don't get frustrated doing the assignment. You shouldn't get frustrated. You understand the stuff. Sometimes you may get stuck, but if we've done our job, you shouldn't find it a particularly difficult assignment to do. So any questions before we get going to make sure I cover them? If not, ask as we go through. Give you a second. No, nothing on the chat. Oh, nobody seems to be typing. So a few things that have come up that a couple students have emailed me about what do I want actually sent in. My recommendation is, since we're doing everything digitally now, and you don't have to worry about printing and paper, and it doesn't make any difference to the markers how much paper there is, honestly, because you just scroll through it. Part of the reason I've posted your assignments as Word documents is so that you can actually edit the assignment and just paste your answers into it. That ensures that if you were to go back and look at that assignment at some subsequent time, I know you aren't going to need it for exams in the same sense that you had with other classes, but it's still helpful to have a complete document. You've got the question and your answer, question and answer, and it all fits together. The other thing that we've encountered is students missing some of the questions as they've gone through. And since there's so many words in the assignment, sometimes it's easy to miss things. It's not like little individual questions you might get in some other courses. But I want you submitted as a PDF. I've configured the sort of Dropbox for assignments, the submit thing to only take PDF. I don't want Excel files. I don't want a whole collection of files. It'll only take one file and in PDF format. A student submitted theirs yesterday, then discovered an error in it. Turns out she found she could delete her submission and repost it again. So it isn't until the assignment closes that you can't go back and change your assignment if you discover something. That's an interesting feature. I didn't know that. That question one, there are two questions which are comment type questions. All I want you, maybe three, I want you to reflect. Think about what you've got there. We too often mechanically do problems without thinking about, does it make any sense to do this, or what does it mean? And you'll find that popping up on each of my assignments. I have a couple of questions that are reflective. There's generally no perfect answer, and well, Any strong indication that you've reflected on the issue is generally acceptable. It's not worth a lot of points. Students have asked about saving stuff. I've on the assignment said save one sheet as data, another as dictionary. If you're saving them in the original data file, they've already got a sheet called data and one called dictionary. In my solutions, I call them Q2 data and Q2 dictionary to associate with question 2. Um, just give them names. I don't want you, and some students have emailed me spreadsheets and they've got tabs labeled sheet 3 and sheet 5, and I don't know what those things are. Label your sheets. It's a habit I want you to build. And there's the question about copy. It says copy the above table of variables and explanations. In the assignment, there is a table of the variables that I want you to look at and their explanation. Just copy that table into your spreadsheet. And if you have trouble doing that, ask me. Question 3, that we've had the trouble with VLOOKUP. I've mentioned this before, just to quickly show you that again. Here's what's happening. That, where was it? That was where's my recoded? Well, okay, I could do it with this one here. And can't remember what one. Suppose I'm using it with home. If I go in here and create a new column, and if this is what happens, if you type in here equals VLOOKUP, V2, where the home is located. I've got a lookup table somewhere. Here's one with home in it. Here. And put the dollar signs in it. 2, and then put in false. Okay. It should execute properly. Whoops, that one didn't at all. Excuse me, maybe I typed the wrong guy here. Let me do that again. Equals. And I'm grabbing from E2. I've got this table. Oh, sorry, home, yes. Oops, and there's my problem. I'm using And that executes properly. But if I was to go back, hold on, delete all those values out here. If this value up here, where it says general, was called text, and Excel does this with some spreadsheets, not others, not all columns, and then type it in, and then get my lookup, and oops. In that instance, let me make this bigger so you can see what it did. It treated everything I typed in as being text. And oops, there's my chat back. Yeah, someone was telling me what to do. Sorry, I had this too big and I couldn't see my chat window. That it's just treating that as text and it doesn't execute. But if I was to go back up and then change this to general, yeah, oh, the other day it worked for me when I went and changed it. But won't this time. I'm going to have to go back, redo it all again, and do it up properly. So it's the key thing here is that keep this column general. Oh, more typos? Excuse me. Okay. That it's something that students don't seem, I haven't gotten further emails on it, so hopefully that means folks are catching that all right. Question 4 is another one where I'm asking you, it's just a reflective question. That was one, the survey that you completed, I had you flag what year you started in as being a list that you could pick from, whereas last year they put in a number. What are the, if they put in a number, it's an interval variable because we can have all kinds of different numbers. It's not ratio because I can't take 2020 and divide by 2018 as to be as a ratio of two different years. Years are uh, uh, interval data, that not ratio data, but it's not important. It's a number they put in. Whereas this year, you didn't get to put in a number. You had to pick from a specific list, which had a very limited number of options. There's good reasons to do both, but they give you different types of data. I just wanted you to think about when you're, if you're creating a survey or a database to store things in, you have those choices as to how to configure the variables. And I want you to think about that question. Question 5 is I'm asking you to do a custom sort. Last term I had it happen. This term I've had at least one student when they went to do the custom sort or sort by color, it says they could see the option, but it was ghosted out. And I believe the students are using Office 365. I pulled up Office 365 and tried to do it, and I had no trouble at all. But I know one student doing it was using a Mac, and that may be a difference there. I'm not quite sure. That Office 365 has limitations to it. And I was told by one of the Help Center staff yesterday that you can download the full version of Excel from the, if you go to that Office 365 site uh, uh, through Smooport, or that's how I got to it, you can actually do an install and install it on your machine. And she indicated it should be a fuller version of Excel. Um, but there are definitely limitations with Office 365. I'll come up with one of those a bit later about histogram and how to work around it. Um, are issues with the product. I don't normally use it, so I haven't encountered these things. That okay, it's a different place on the Mac. You've got to do it a different way. Okay, it does work in 365. Thank you guys. That I appreciate this. Um, I don't use a Mac, and as I said, I don't use 365. So these different configurations of Excel are causing a lot of frustration among you. And I don't have an easy solution other than if you've encountered a problem or know a solution to it, pass it on and I'll post it so that we can share that type of thing. One student asked with question 6, I asked how many students are outside Canada. Uh, there's actually outside Canada, it was pointed out, appears in 2 places. Under home, I've got a location being outside Canada. And I asked you where you're living right now. I was really looking at where you're originally from before you came to St. Mary's. Did you come from outside of Canada? Uh, if you end up have already done it with live now and use that variable, then fine. But I don't think live now was one of the variables I asked you to extract. In question 7b, I ask you to do a bit of a filter on the number of hours studying to limit it to 5 to 50. In question 7c, I then asked you about how many hours you spend doing recreation activities. Should you keep the filter on? The intent was no, to take it off. But if you did it by accident and left it on, I'll instruct the markers to just leave it because the instructions weren't there. In question 6, I made it clear, take the filters off after each step. So then there's question 8, and we're getting 2 issues with histogram. One is Office 365 doesn't have data analysis. I didn't know that. Nobody told me that before. So we've been searching to find how do you address that. If you're in 365, there's a tab called Insert. On it, there's a thing called Add-ins. There are no add-ins for it, but you can download some. You go to Category and Data Analytics and scroll down, and the one to use is called XL Miner. That's a commercial product that it looks like there's a stripped down version with just the statistics functions, and you can download that, and it works very similar to the standard one that's within Excel, and so you can use it to do a histogram. We're going to need it for some stuff later in another 2 weeks, I think. The other thing is a very bizarre problem that seems to be an Excel thing, and we've yet to figure out what the cause is. Some students are doing their histogram. They're defining the bins as it suggests in the assignment, as in steps of 1,000, 2,000, 3,000, 4,000, and down. And then when they do their histogram, Excel goes and changes the bins to all kinds of other things. Don't know why. So don't get anxious about that. Submit what you've got. Students have sent me their spreadsheets in the past on that one, and I've tried everything to try to fix it, and I can't. Excel still goes and switches what the bins are. I don't know why. Technology. Those are all of the things students have raised with me about the assignment so far. I don't know if there's anything anybody else has run into that's giving them grief. Um, Nobody's typed anything. No? Okay. You will find a lot of my assignments are not puzzles to solve like you'd get with math problems. They're fairly directive. They're telling you to do specific tasks, and it's to get you to practice using these tasks. I want you to get comfortable with Excel. Many of you use it only because you have to, but when you graduate, every workplace lives in Excel. That's how they manage data on a day. They may use custom software that customer relationship management systems or whatever, but many of them behave like Excel. If you're doing accounting and finance, they manage all the numbers in Excel. They may use other systems, but Excel is like their calculator. It's become an essential tool, and employers are complaining that a lot of university graduates, business graduates, have very rudimentary Excel skills, and none of them have any data skills. The stuff you're doing in this class, countless employers have said, no, our employees can't do anything that we do in our class. And that is a problem. So I'm just making a practice that the more you use it, the more comfortable you'll get. It's frustrating because, as I pointed out, Excel does some very strange things. Nonetheless, it's a very useful tool. Anyway, that we're into new stuff. And now it's actually getting into fun stuff of looking at data. For me, it's fun stuff. That, and I enjoy looking at data. Here, I'll just show you. Here's my mail today and why data drives me in different ways. I don't know how well you can see this. There's very little data about universities, educational data. Let me see if I can shrink this so I can see. This came in just before class at 8 o'clock this morning. And that most universities and most governments don't publish data on to do with students. Ontario publishes on a very frequent basis data about applications. So the question is, how is COVID affecting applications to university, and what programs, what universities? And this is a simple time series of just tracking this over time, over the last 15 years. And this is by field of study, how many applications there are. And you will see that blue line is applications into arts programs. And about 10 years ago, arts went through a sharp downturn, and then it's leveled off. Here's this year. They're down about 12 to 15%, which is huge drop in applications across Ontario. That the scale over here is going from somewhere in the vicinity of 23,000 applications to 20,000, 3,000 less students studying arts. Business, that's the orange. Business isn't changing. Where the uptick is in STEM fields, uh, probably engineering driving a lot of that, and health fields. Big jumps there as well. Not surprising. But such huge swings in a single year are uncommon. As you see, it tends to drift. These are very, very sharp changes. That if you're thinking of products, switching from one product to another, and if you're not in the business of producing STEM and producing health, but you're very big at producing arts program, imagine locally, a place like King's. This would be brutal on an institution like King's. This is great news for an institution like Dalhousie. The other is, do they change university preferences? And this is 1 year changes in applications percentage wise. McMaster, a really big institution. So if you've got 25,000 students, to move you up by 1,000 means a 4% increase in enrollment. That's a lot. That's 1,000 students. Where are you going to put them in Hamilton? They're up 18%. That's thousands and thousands more students pick McMaster as their first choice institution, right through the roof. Whereas at the other end, an institution like Brock is down almost 15%. That's devastating. Brock is fairly large, probably 14, 15,000 students. So being down 15 is like losing 2,000 students to them. Big, big, big problem. Um, Tracking data, I'd say it was my previous life. I'm always looking at these. These are massive swings. We've never seen the likes of this in Ontario before. We've got some institutions that are incredibly popular this year, large numbers where it's down, and probably overall applications are down. Uh, so they've switched programs, switched universities. Uh, Looking at patterns is, whoops, where are we? Back here. Um, and looking at those and how should you plan for it? Those institutions only have a very short time to do the planning. I don't know about online. That this is in Ontario, you'll have to apply through a central application center. All applications to Ontario universities go through one body, and they publish data every month as to um, applications by program, by institution, and students sign off on what's their first choice, second choice, third choice. So uh, fairly rich data. Um, but by the looks of things, these institutions across Ontario are having significant capacity problems. Either they're going to have far too many students, and they're necessarily a bad thing. Others have very huge drops in students in some programs, and maybe increases in others. But the swings are more than we've ever seen before. And it's very, very difficult to change your capacity to scale up or scale down. So, but looking for patterns, firms have got to be doing this constantly. They're looking at changes, uh, patterns in accounting records, in marketing and sales data, and so on to know how to respond. Uh, that it's interesting. I As I said, I only got this data at 8 o'clock this morning, so it was just a shock to see it. So last class we were looking at simple summary measures. Where's the middle, what's high, what's low, those sorts of things. But you're looking at only at one variable. I look at those things at times to get a sense of each variable. I like, for many of my variables, to have a lot of variability. The more variability, it's the more information I've got. I know about good people and bad people. They aren't all the same. And when they're not all the same, it gives me greater insight. So that's sometimes useful to me. But in the end, I'm looking at patterns. What I just showed you were changes one year to the next. That's a pattern. Changes over time, changes by program. So I'm looking at old enrollment and program, two things at the same time. And how do they compare? Well, what tools do we have for doing that? That's what we're going to start looking at today. So I've given you some quickie summary measures last time. And one I'll come back to a bit later called standard error, which is we're going to be looking today at some averages, and the averages are not going to be precise. There's going to be some error in them. Standard error will be, even if I don't have the number, it's something I'm going to think about, that everything is an estimate. So we're getting into a thing called pivot tables. That this is, I wish I'd discovered them many years before I did. I've been using them for a decade or more. More than that probably, but I wish I'd known about them earlier than that. They're just wonderful tools. They're the best part of Excel for me if your interest is in data. Excel's analysis toolkit is awful. It's very, very weak. It can only do very simple things. It's still the same as it was 15 years ago. It's not been upgraded or improved, and it's incredibly limiting in how you can do things, but you have to work hard to do it. But it's the only quick, readily available toolkit that everybody might have on their desktop. But pivot tables and pivot charts are also a feature of Excel that is standard in Excel. And this is a very, very powerful tool and doesn't get nearly enough attention. It's generally not taught in a stats course, and it should be. So let me go and show you what it's about. I'm going to go to my data set, and I just want to go, yeah, this is the one. Here's my data that we've been using. I've recoded it with in a lot of different ways. Oh dear, I've still got other stuff in here. I haven't cleaned it up. I've got a whole bunch of different variables in here that are ones that we've been looking at, okay, and some others. I've recoded some of the feedback students gave us about how concerned they are about their job. If I go and pick any cell in here, okay, and I go up to insert, you'll see table is ghosted out because I'm in a table now. But this is the way we created our table before it was going into this thing here. Click pivot table. It will generally, like when I pick table, identify the block where all the data is. And it's good at picking that. And always put it in a new worksheet. Okay, so I'll create a new worksheet. So it's new sheet 2, and I should rename it. And so I'll call it pivot. Try to remember to rename it right away because you'll forget what they are. This sheet here, like we've had before, it's got some junk thrown over here. It's got no data at all, but it has all my variables listed here, plus the odd other one. I've got to edit this further. So I've got all my variables in a list. It calls them fields. So variables, columns in a table are called fields. Okay, more language. And I'm going to put them into a table. A table has rows across and columns. And then it has stuff in the body of the table. So I can put different variables in the columns, different ones in the rows, and I can summarize different values. And I also have filters, a whole bunch of different things here. So let me follow my slides so I don't get mixed up. So I'm going to create this table. Okay? And as I said, I've got rows that's what am I trying to summarize across in my table? I got columns, what I'm going to try to summarize down. What am I summarizing? Those are values. And do I look at everybody? Do I maybe just look at Nova Scotia students? I could do a filter to do that. There are many things I can do. So let's go and start building a table here. Oh, come on. Oh, it won't move my head. This sometimes happens, it seems, with, no. So my presentation's frozen. So I'll go to plan B. And I'm going to go to my slides here for today. I'm going to shrink them down. Oops. Yep. And I'll just do it this way. Okay. I'm going to go over to the fields list, and that's the list of variables. And I'm going to put the programs in the rows of my table. So let me go back here. In here, I've got programs. I can take program and I'm going to drag it to rows. And make this bigger so you can see. So I've got art, business, invalid, science, and not applicable blanks that I had there. Okay. Now what am I going to do to it? So I'm now going to drag gender and put it into the column. So let me go back here. In my list here, I've got gender somewhere. There it is. Drag it to the columns box. Okay, so I've got a table. It's going to talk about what program a student is in, what their gender is. Okay, and I've got blanks here that are just as a blank column, female, male. Notice these are in alphabetical order. That's their normal sequence. Okay. And now I'm going to look at salary. So I want to compare salaries among these. So let's just go and let's drag it in there first and then see what it's doing to me. So, yes, hold on. Let me show you something quickly. So I've got salary. I'm going to put it here. And Patrick, I'm going to get to yours in just a minute then. Okay. So when I dragged it in, it's got a whole bunch of numbers in here. It's different from my PowerPoint slides. I never know quite what it's going to do here. I dragged in salary. I don't know if you can see what's written down in the corner here, but it says count of salary. This is telling me I have 752 students that reported their salary. I've got 230 males, 399 females, 123 blanks. I've got 217 arts, 285 business, 70 invalid, 118 science, 8 blanks. So now I've done it this way around. Patrick asked, could I do it, I think, the other way. Let me just drag them around. Same table, I've just flipped it around. So I can flip it whichever way. And next class in particular, we're going to be looking at flipping and how that changes some things. I don't think I'll do it today, but it does affect how we sometimes visually interpret data. Particularly next class in particular, I want to look at doing this not just in a table, but in a chart, do a picture of my data. And where you put things in rows and columns will affect the way the picture looks. And it isn't just flipping the picture around. It actually can do some funny things to it because of the nature of the pictures. Let me just stick with the format I've got with it. But I don't want the count. What I'd like to know is what the average salary looks like. So click on count of salary. It's down here in the values box. And there's a list that comes up that may be hard to read, but the last entry says value field settings. Click on that. This is a box you're going to use a lot. You're going to use it over and over again. And it does all kinds of different things. That first off, it says that it's got count of salary as it's doing it. And it says here, summarize value field by. Those are the words that are there. And it can do sum. In my slides, it has sum, or count, or average, or a whole bunch of things that you can do. Okay? I want average. If I did that, I get this. Ick. Ugly numbers. Let me go back here. So this will do that sort of thing. I like generally to go to number format and format my numbers so that they're visually more appealing. I'll keep saying throughout the course, I'm a visual person, and almost everybody I work with has always been a visual person. So make it visually appealing. It makes understanding it easier. These are dollar amounts, so let's make it currency. The numbers are going to be big, so I don't need decimal places. So I'm going to take those out and click OK, and then click OK again. So here's my new table. And I'm just going to move over a little bit. Yeah, no, I don't need the totals over there. Let me leave it here then. From here, you can start seeing patterns. We can see that males think they're going to earn more than females in arts and in business and in the invalid group. Among science, it's the other way around. Females earning more than males. Interesting. And the blanks, no. We did some of those numbers before with a total row where we did filters on males and females and looked at the total row for arts and business and so on. A lot of work. I've done it all in one nice, neat table, but it's still got some clutter in there. What do I suggest we do to this? So I've just changed it to give me average salary, and I've changed the numbers to being dollars, and I got this result that I just showed you. Okay. But it's still got clutter in there. That the blanks for gender, I don't know what to do with that. Let's hide them. Okay. And similarly, I don't want the invalid and the not applicable. So let me go back to my table here. If I go to the row labels here, okay, and I've got a little down arrow, click on it. It gives me what values I've got. Invalid, I don't want. And not applicable, I don't want. Click OK. That's better. And in the columns, there's a down arrow. Click on it. I don't want the blanks. Here. Smaller, more compact table with no clutter in it. Clean things up. Clean workplace, you make fewer mistakes. Fewer accidents happen. That same thing applies in terms of trying to understand data. Get the garbage out of the way. Throw the trash out. So, but I've got another problem here. We know there are crazy numbers like the $650,000 salaries and the zero salaries. So why don't I do some filtering? So to do that, I've got to say, what am I going to filter on? Well, I've summarized salary, but I can also go and filter on it at the same time. Drag it to filter. So salary is down here, salary is also here. So I can have the same thing in two places. Well, generally in filter and in values, I can have something. Okay? And now, if I scroll up, you should see it sitting up here. And so in my pivot table, if it's sitting up in the top corner, it's something I'm filtering on. And there's a down arrow for it, and I can do my filtering. It's not as, whoops, what's gone on here? Hold on. I must have done something here. Excuse me. I played with this earlier to show you something later. Hold on a second. There we go. I'll explain to you later what I just did. Sometimes when you've done things with a spreadsheet and you're messing around, you think, oh, well, I've left that, thrown it away, I've thrown it back into this list. Some of the stuff you may have done to it previously may still be there hiding behind something. So let me get my salary back here to filter. Oh, there I go. When I do, although I'm filtering here, before we could do things like number filters. That you've done that in your assignment. Filter was fairly powerful in a table. It's not nearly as powerful in a pivot table. All you can do is select specific values. I go to select multiple items, and I'm going to get rid of little tiny ones. So these are all the different sorts of values students gave us. Let me stop at 10,000. I should, not sure what I've said in the slides I'm going to do. And at the other end, I'm going to get rid of blanks and the crazy big numbers. Oops. But it's tedious. I've got to click each one by one by one. There. So that gets rid of silly numbers. Let's see if that improves things here. Oh, changes things a lot in science. Remember before in science I had 61,000 for females and males it was somewhat lower? Once I take out the crazy numbers, changes around. Now you look at it and I'm seeing in arts, males expect to earn $5,000 more. In business, they expect to earn about $5,000 more. And in science, they expect to earn about $7,000 more than women. Huge differences in salary expectations. At least they look to be big to me. What my slides say I'm supposed to be telling you. So I just did it. Oh, sorry. In my slides, I went down to 20,000. Let me do this to make it consistent. Go back here again, just so the video of the lecture and the slides tell the same story. Okay. There we go. So now it corresponds to the slides. So from this, we can start seeing patterns in one picture. And that's what I'm looking at is as patterns in relationships. And I know that once they're into the workplace, that traditionally males earn more than females. Bunch of different reasons. Part of it would appear to be discrimination in the workplace. Um, but it was surprising to see that their expectations before taking on a job are also different from each other, males and females. Actually, by taking out those low income ones, it's made them a little bit more similar than we had before. The gap isn't quite as big, or is much less in arts now, and it's a little bit smaller in science. But it's still the case that we've got quite a pattern here. So in this instance, if I see this type of shift taking place, I'd want to drill down and find out why. Is there a particular reason that I can identify at the outset that um, the averages are only an estimate? Okay, that I've taken 752 values. I've stripped out the crazy ones that were too high and too low. I've taken out the invalid ones. I've taken out the blank ones. So I don't have as much data anymore. And then I've put it into 6 boxes. Okay. That look at this. I've got, so, maybe I'm down to 600 values and then into 6 boxes. It's maybe 100 in each. But maybe some of these are very, very small. So generally, if you're looking at a pattern and you see it sort of jump out at you and you might worry about it, you think, is it real? Well, if I'm dealing with a very small sample, it might not be. If I'm dealing with a very big sample, it's probably real. So let's check to see how many we've got. I can do this 2 ways. I could drag the salary back in here, but an easier way might be to pick a different variable. I like to have 2 variables at the same time. And this is sum of IDs. I don't want the sum of them. Give me the count, please. Okay. So let me just get this out of the way so we can see everything. So, whoa, we're down to only 531 values after we've done our cleaning of different groups, extreme values, and the like. I've now only got 212 art students, 226 business, 93 science students. Let me, if you don't mind, make some of these columns narrower so I can see everything better. Okay. So now you can see in my table, for business, I've got reasonably big samples, more than 100 of males and more than 100 females. In arts, I've got a lot of females, not all that many males, but still a fair number. In science, small numbers, but they aren't super small. These would suggest to me that these estimates might be off by some amount. It could be off by $1,000, $2,000. The difference between 2 groups is this difference in arts. Maybe it's not as big as I think it is. If I took another survey, another group of students, I'd get different numbers for these averages. And would I still see this big difference between them? I might not. I'm probably going to still see some difference. These samples are reasonably large, but if I had samples that were down to 8 students, if I took engineering and split, or science and split engineering out, I'm going to find I've only got like 8 engineers or 4 engineers. Of female engineers, I'm probably only going to have 2. It's a very small number. They're a very small representation in the engineering program. In those instances, those numbers wouldn't be, samples aren't big enough to get reliable data. I'd be very cautious about using it. So it's just a habit to get into, is to look at count. So here, I guess I drag salary into that count box, but I've got the same results I was just showing you. Actually, I think it's 26, same. I think I've got fewer art students for some reason. I'm not sure. I probably did something crazy. Here's, if I exploded it out and looked at all programs, here are the ones that didn't tell me anything. Those sample sizes are really tiny. If I look at the invalid ones, this count for males, it's too small to be reliable. Be very cautious with small samples about drawing conclusions. That I don't know if you ever follow election results, and that night of an election when the results are coming in, the most recent one with the US election. They come in poll by poll, and sometimes they'll be talking about, so and so is leading over someone else, and it's based upon one poll coming in with the responses of 23 people. That so okay, you've got out of the 23, 15 like one person and 8 wanted the other, and they're commenting about that, and you'll find the TV commentators talking at length over that. It's garbage data. Until they've got a few thousand votes in, you can't call those sorts of things. But they'll comment on anything because they have to fill up airtime. But be careful. I've seen managers comment on samples that were ridiculously small. It made no sense. That Let me go back and look at those odd ones. What I could do is try to collapse them together. Let me do that. So I've got these here, okay, and let me take all the labels, put them back in here again, okay. So here's the table that's in the slides, okay, that has all of these other groups in it. But suppose I want to take this invalid group and the not applicable. They are strange in some fashion. And I'd like to combine them, at least to take these 8 observations and do something with them. What I can do, click on invalid. Okay? I hold my control key and click on not applicable. Didn't work. Do that again. Okay, I've got both of them lit up. Now I right click on it. And you see a variety of options here that I can do. And one of them is called group. Hit group. Okay. So my spreadsheet's a little different here. Science, science, business, business, arts, arts. It's created groups. It grouped those two together, called it group 1. And then the other ones that I hadn't picked, it also makes them, in a sense, called groups. You can collapse these. So if you are doing grouping, and I'm going to make you do this on assignment 2, once you do a group, collapse the group. Because generally we're grouping because we want a high detail. Group that. Let's group 1. Collapse it. Science. Group 1. Group 1, strange name. You can type on it and give it a new name. I'm going to call it other. So now I've got it in a form that I've brought in that other one. The samples are a little bit bigger now because I've combined these 2 small ones. And I could even start looking at comparing them. Notice even for this other group, males expect to earn a lot more than females once I've combined all that stuff together. So if I've got a list of categories and some categories have small frequencies, combine them, group them together to make a bigger bundle so that I can, when I've got bigger bundles, these estimates of salary are more accurate. That there is some error in them, but the error will be smaller. And it's a subjective thing. There's no fixed answer for that as to what you should be doing. Okay. And so that's what I did. And then I got this one was my new and improved table. And somehow I've got different things than what I just showed you. I've got more. Now I'm up to, okay. And the other is, you might note in Excel, it did some other things for me. I've hidden this fields table over here. If I go up here to analyze, okay, my field list that I had, that column of things, click on it, now I can bring it back. And you will notice down here, I've got program that I've summarized the rows with, and I've created, in a sense, a new variable called program 3, which is the grouped variable. So program is the original, program 3 is the grouped one. Okay. I already had one called program 2 before in my field list. How am I for time? Okay, I've got a bit of time left. Let me go, and I'm trying to find other reasons for the differences between the two. And one of the ones that I think I mentioned to you before, I often like to look at parental expectations. Parents can be a real pain, being one. Um, I'm just going to throw this out for, oh, let me throw it out for now. I'm going to throw out program 3, and parent education. And I'm curious as to if your parents have a high level of education, probably in high income jobs. So the students grew up in a wealthier household. Do they expect to earn more than when they graduate than those that grew up in a household with parents with a low level of education? And when you look at it, well, there's some clutter in here, and I should probably show you frequency counts as well. Whoops, get that count of ID. Okay. Oh dear. Here I've got some really small samples. I got 7 and 3 and 11. These are of doctoral degrees. Understandably, not sure, don't know about that. That I'm going to get rid of the not sure, don't know, because I don't know what to do with it. I'm going to look at some of these others. If you've got a doctorate, a professional degree, it's a second degree, a master's, and more. Let's call these, I'm going to click on doctorate and master's and professional. And I'm going to say, let's group those ones together. Okay, and I'll call this graduate degrees. Okay. I'm going to collapse these. So now I've got better sample sizes here. Okay. If you don't mind, I'm going to take this out of our way so you can see what's happening. And so you see my sample sizes are reasonable size over here. I don't have anybody that's super, super small. So probably, yeah, I don't need, excuse me, this guy anymore. That's clutter. So I'm comfortable my numbers are all right. But when I look at it, look at the different levels of education, and you find they aren't going from like level of education is an ordinal variable, that there's an order to them. So let's put these in order. Let me take high school. I'm going to right click it. And one of my options down here is called move. And I'm going to move it right to the beginning. Boom. And college comes between high school and bachelor. So let me go and click on it. And I'll hit move. And I'm just going to move it up. Boom. So now I'm looking at high school, college, bachelor's, graduate degree. So in term that probably gives me a rough indication of socioeconomic background of the student. And if you look at it, let's not look at gender here, you'll see they're almost all the same. They might increase a little tiny bit, but with our margin of error, no, there's no real difference. So it doesn't matter if the students are coming from highly educated households or lower levels of education households. The expectations of the students are about the same on average. Does it matter between males and females? Again, looking down the column for males, not really. And for females, not really. You'll notice that they bounce up and down and up and down. There's no pattern here. What's an example of a professional degree? Law, medicine, um, that uh, usually done as a second degree, but you get a professional designation with it. Some think of if you want to become a CPA. I know you don't go to a university to get that second credential, but often you have to do additional courses, write exams, professional certification, and you need a bachelor's degree first to get there. So that would be viewed as, you might think of, uh, if your mother is a CPA, is a chartered accountant, then you might think of that as having a professional degree. It didn't come right out of the bachelor's degree or bachelor in accounting. You've got to do more to get it, and it's beyond a first undergraduate degree. Um, so this is an instance where I was expecting a pattern, and I didn't see it at all. Uh, it was actually gratifying. They say that university is the great leveler. It helps bring up people from lower socioeconomic backgrounds up to a comparable level, and particularly with Canadian institutions where there's a lot of similarity across them, it does level people. In the U.S., we're not seeing the same pattern to the same degree. There, it matters to some extent what university you go to, because some firms are very elitist in their hiring, and it has nothing to do with the student's ability. We don't see that to the same extent in Canada. Not really a large amount at all. There hasn't been, at least in the research. So um, this is what I showed you, and we did our grouping, and then we did the sorting, and I did all those sorts of things there. I tried to summarize it, and this is the table I've got right now. But I would not read much into this because these are just estimates. If there were differences of $5,000 or $6,000 between high school and graduate, I might pay attention to that. That's a 10% increase. But what we're seeing here is a 1 or 2%. That's nothing. It's if I took a different sample of students, I'd probably get different results. So always be careful with these things, that they are just estimates. That um, and I just want to caution you that if I mentioned before, I went and messed up some of my data. If I go over here, I'm not sure if it's still going to show. There it is. I filtered on salary. I filtered on gender. I filtered on parental education. I've left out the don't knows. And on my new variable that I just created, I haven't filtered on anything else. The only thing that shows in my filter box though is salary. Okay. Uh, that if you see in your list funnels, that means you've been doing filtering. And sometimes you forget you've done filtering. That this sometimes helps show me things that I've done that I may have forgotten I've done. Um, it's sometimes I get led astray in my analysis because I've forgotten I've done certain tasks, and that I may not be looking at everybody. That um, if I looked at when they started as another example, um, and this one is not important as an example, but whoops, wrong sheet. So I'll throw this out. I went looking to see, are there all kinds of different reasons why students are giving me different answers? And one of them I looked at is when they started. Now, um, this survey was done in 2010 in the winter. So these are first year students, 2009, second year, third year. There's just too many rows here. I'm going to group these. Okay, and we'll call it. Most of the time we have trouble processing more than 3 or 4 pieces of information at once. And so I tend to try to collapse my data so that I've only got a small number of groups that I'm looking at. I get easily overwhelmed. Most people do. Uh, what I found a little bit interesting here, these are first year students. These are students approaching graduation, and you will find that the salary expectations of first year students are much higher than those approaching graduation. Maybe not surprising. If you just started university, you haven't really looked at the jobs that are out there. If you're approaching graduation, you've started looking, you've started applying for jobs that for those that started in 2006 or before, in March, they are probably looking at graduation. And many of them have applied for jobs and they know what the pay is like out there. And so it was interesting to look at your expectations change over time. So there are a lot of different patterns we can explore in a simple data file. But maybe I want to graph it. And this is the last bit I think I'm doing today, if I remember correctly. Excuse me. This I grouped it too much. I just want it to be looking like I had before. I can go back here and ungroup. There we go. And I'm just going to group these ones. Okay. And I'm going to collapse these all. And I'm going to get rid of my blanks. If I was to present this to an audience, I know some of them would get, it's too busy, too many numbers, too many digits. It'd be nice if I could round these off to the nearest thousand. Makes it easier to read. I might take away the dollar signs because I know they're all dollars. But even better still, maybe just give them a picture. So if I'm looking at how do salary expectations change based upon where they are in their program and what their gender is, go up to Analyze and click Pivot Chart. It'll suggest a variety of charts. For these one, most of the time, the standard pivot chart, is a column chart, clustered column chart. Columns because they're going up and down and they're clustered. And so this is neat. I can go and look at the blue is females, orange is male. Oh, females expect. So the older students, females expect to earn less. And then these are the ones in their fourth year. Same thing, same thing, same thing, same thing. Pretty close here, but it looks like in general, females expect to earn less. And the salary expectations are generally going up. So the closer they are to graduation, the lower their salary expectations are than when they first started out in their degree program. I haven't even looked at the numbers over here on the left. I'm looking for patterns, and pictures are great to show patterns. If I put this type of thing in there, and I can go and format this thing, I can add a title. Let me put it in here. And typo. Give it a name. I can format the axes if I want. This is great in terms of a different thing that I can do. If I wanted to, you'll notice I've still got these funny things here. I can go over here to gender. And if I wanted to put the blanks in there for some reason, I can put them in as another column. So blue is now for blank, orange for female, gray for male. The blanks have higher expectations than anybody, it seems. So I can actually do some operations that are similar to ones I would do in the pivot table. I can do directly in the chart. And if I change things in my table here, hard to fit everything together here. Maybe, if you don't mind, I'll do this. I'm going to bring my field list in, and I could go and, okay, I don't want to look at this. I'm going to go back. I want to look at program that I had before. And so I can go and look at different programs and do a chart. If you want to explore your data and you aren't a numbers person, you're a picture person, you can start going and doing it here in the same fashion. Program, I'm going to hide these funny ones. There I go. Now I can see how they vary across programs. And when we're looking at pictures, we're not looking at the numbers. The numbers are distracting. And even if you look at the scale, it's only giving you nice big round numbers, 10,000, 20,000, 30,000. Not a lot of detail. But if you're looking for patterns, you don't need detail. So think about how you process information. That don't get obsessed with things like accuracy and that type of thing. So we're going to get more into charts next class. I'm coming up to my time limit, and we'll be doing a lot more charting, but we'll be looking at how to summarize stuff that's more in categories. And I'm going to show you a slick way to do histograms that is much nicer than the histogram function that we did. So what I did today is you need to do a table. A table has rows, a table has columns. How do you pick rows? How do you pick columns? How can you format the different summary measures? Are you looking at averages? Are you looking at counts? We'll look at some other summary measures next class. How do you filter things out? Hiding things, doing it that way. Grouping things together to give you less detail to see the overall pattern. Reordering things so that there's maybe a natural sequence in there that you'd like to show. And then how to turn it into a picture. Several cautions though. The measures that I got are estimates. So those averages that I had are estimates. Don't read too much into it. So if it said 52,400, maybe that's 51,000. Maybe it's 55,000 is the right number. I may be off by a little bit. So don't worry about the small stuff. And small percentage changes probably aren't important. That becomes a bigger issue as you make bigger tables. If you've got more rows, more columns, then you're spreading your data out over more little boxes. And you've probably got some boxes with small numbers in them, small counts. That can be dangerous. So normally, unless you've got a very, very big data set, try to keep your table with a small number of rows, small number of columns, so that there's enough information in each box. And also, when you are hiding rows and columns, remember that you are filtering. And don't forget that. It makes it nicer, neater, and so on. But you're hiding stuff. And are you hiding things that are important? It's just something to remember. Most of the time, no, it's not a problem. But don't forget what you're doing. When you're cleaning things up to make it look nicer, you're maybe what you've thrown away is the most important thing that was there. So next time I'm going to look at histograms, so grouping numeric variables. We did grouping of rows. How do I group numbers values? And looking at categorical variables. So if I was looking at students' concern about finding a job, is that do art students, they have lower salary expectations? Are they also more concerned about finding a job? Is there a pattern there between program and worry about employment after graduation? And so we can get back into that. Those ones, the charts and the tables, when we're looking at frequency data, just counting stuff of categories, at first glance, you may think it's going to be simpler. It's actually more complicated to interpret, and we make more mistakes in our interpretation. we'll leave that to next time. So we're done. Good luck with the assignment. If you got questions, send me emails. I'll try to follow up quickly. I'm expecting good results. You guys have done so well on the quizzes and tests. I've got high expectations of you with the assignment as well. But take care. We'll see where it goes. Bye now.